Hi, hello. Welcome to a new video. In today's video, we are going to see about diffusion principle in biological system. Okay, so here we had to see what is diffusion. Diffusion is nothing but the movement of molecules or particles from the higher concentration to lower concentration. Okay, that we will call it as diffusion. Okay, so what is the role of diffusion in the solubility? So we can tell if we have the higher solubility, we'll get the better diffusion. If the better diffusion means we'll get the better absorption. So in diffusion principle, you must have to remember that only if the dissolution is taking place only we'll get the good diffusion. Okay, so we have four types of diffusion. So first one is the passive diffusion, facilitated diffusion, active transport, filtration or pore transport. So the passive diffusion is nothing but most of the follow will be this pass is following the passive diffusion. Okay, so it moves from the moves down the concentration gradient. That means in the passive diffusion, drugs will move from the higher concentration to lower concentration. So most of the drug will be following the passive diffusion, and no energy is required for the passive diffusion. And you can give example like aspirin, paracetamol. Okay, and comes to the facilitated diffusion. Facilitated diffusion means with the help of a carrier. If the um, with the help of a carrier, if your diffusion is taking place, means we'll call it as carrier mediator. Example is, we can tell polar drugs is an example for the facilitated diffusion. So it the transport down the gradient. In the passive and active cases, transport will be down to the concentration gradient. Okay, next comes to the active transport. So active transport is not important for the drugs. Okay, here it will be for the nutrient supply. So movement against the gradient with the help of a ATP. So active transport we required energy. Okay, so next comes to the filtration part. Filtration here we will call it as pore transport. Why? Because solvent solute moves under the hydrostatic pressure through the porous membrane. That will called as the filtration diffusion. Here pore transport. Okay, so these are the types of diffusion. Next, in diffusion, if it is there, means you have to study the Fick's law of diffusion. Okay, as per the Fick's law of diffusion, we have two types of law. Fick's has Fick's first law as well as Fick's second law. So Fick's, according to the Fick's first law, okay, it is for steady state diffusion. That means we will state the Fick's first law states that diffusion flux is proportional to the concentration gradient. So when concentration does not depend upon time. Okay, concentration does not depend with the time. So we will write J is equal to minus dC by x. What applies when concentration does not change with time. Okay, so here the J is the flux, D is the diffusion coefficient, dC by dx concentration gradient, and this negative sign indicates the higher concentrations to lower concentration movement of the molecules. Okay, next, what are the factors which affecting the Fick's first law? First case is the diffusion coefficient. Diffusion coefficient tells that how much diffusion is taking place. Okay, so if we are increasing the temperature, the diffusion coefficient also will increases. If we are increasing the solubility, there also increases the diffusion coefficient. If we are reducing the molecular size, the diffusion coefficient also will increases. and comes to the surface area. We know if the surface area is more, the dissolution will takes place fast. The same principle applicable here. If the surface area is more, we will get diffusion faster. Then comes to the thickness of the membrane. Okay, so if higher thickness, if more is the thickness, means diffusion rate will be slow. Okay, so thinner means thinner membrane means diffusion will take place faster. Next comes to the concentration gradient. Depends upon the concentration gradient, your diffusion also will changes. Next comes to the fixed second law. Okay, so the fixed second law is for the non-steady state diffusion. Non-steady state diffusion means it applies when concentration changes with time. In the first case, it is concentration does not change with time, and in the second case, concentration changes with time. So we will tell dC by dt is equal to d into d square c by dx square. Okay, so in overall here you have to remember higher solubility, it will give the better diffusion. If the better diffusion if we will get, it will be absorption will be better. Okay, so diffusion means movement of molecules or particles from the higher concentrations to lower concentration, and we have four types: passive, facilitated, active, and filtration. In the case of passive, it is for the most of drugs is for following the passive diffusion. No energy is required, it moves downwards. Okay, facilitated, it is with the help of a carrier, and active transport, it's a movement against the gradient. Okay, it is especially for the nutrient supply. And filtration example you can give porous capillaries as well as the filtration in the kidneys. Okay, glomerular filtration will give the example in the case of filtration. Okay, fixed first law, steady state. Steady state means it is when concentration does not change with the time. So fixed first law says that diffusion flux is proportional to the concentration gradient. And fixed second law, as per the fixed second law, is for non-steady state diffusion. That means concentration changes with time. Okay, so I hope you people understood this portion. Now we will see in the biological membranes, a biological system, how the diffusion is taking place. Yeah, now we will talk about diffusion through the biological membranes. Okay, so we know the biological membranes are lipid bilayers. What? Biological membranes are lipid bilayers. So drug diffusion depends upon several factors such as lipid solubility. What is lipid solubility? Lipid solubility, the drugs which will be soluble in our lipid bilayers. If you are taking the lipophilic drugs, it will get easily diffused in our biological membranes. Okay, instead of that, if you are taking the hydrophilic drugs, diffusion will be slower. Then comes to the degree of ionization. In the case pH or pK. So unionized form will be lipid soluble. Okay, so we will get the faster diffusion. Ionized form will be water soluble, so it will be slower diffusion. Next comes to the molecular size. Molecular size means if molecular size is smaller, we'll get diffusion faster. If the molecular size is larger, diffusion rate also will reduce. Okay. Next comes to the partition coefficient. Partition coefficient is nothing but the ratio between the organic phase by aqueous phase. So we can write P is equal to C organic by C aqueous. Okay, this is the ratio between concentration in the organic phase by concentration in the aqueous phase. So if we are having the higher partition coefficient, it will be more lipophilic. So since we will get the better diffusion. Okay, this is very important concept in the diffusion through the biological membranes. So now we will talk about how the drug will diffuse in the biological system. Previously we had seen the types of diffusion. Okay, here we are seeing what is the mechanism is happening when the drug is diffusing in our biological system. So we have four types here. First one is the transcellular diffusion. Okay, most drugs will be following the transcellular diffusion. So we can remember which will passes through the cell membrane. That means lipophilic drugs are the example of transcellular diffusion. And when we are talking about the paracellular diffusion, your drugs will passes between the cells via tight junctions. So that is example we can give hydrophilic drugs. Okay, now we will come for the facilitated diffusion case. Facilitated diffusion is a carrier mediated. Okay, so carrier mediated, in that carrier protein is involved, so no energy is required. Example is route transport and vitamins we can give as a examples here. Okay, next comes to the osmosis part. Osmosis is nothing but the movement of solvent across the semi-permeable membrane will called as osmosis. Okay, so in the cases osmosis, you can give your RBC in distilled water as an example. What RBC, red blood cells, we are taking in the distilled water. Okay, so it will get swelled. Okay, and it will swell as well as it will burst in the certain concentration. Okay, that process we can call as hemolysis. Okay, so overall, in the case of diffusion principles, if you are talking about some dosage forms as an example, we can tell if tablets, in that case dissolution have to take place, right? First dissolution, then it will get diffused. Okay, so if you are talking about the injections, if you are taking the insulin as an example, insulin is having the larger protein, so diffusion won't take place. So we will inject, right? So usually the insulin we will inject. Okay, these are the certain examples of your biological membrane, how it is crossing, how what's on based on that, how we are making the dosage forms. Okay, so I hope you people understood basic things. Now I will just recap in 1 second. Like, first, in the case, you have to remember what is diffusion. Is the movement of molecules from the higher concentrations to lower concentrations, and we have four types. What are the four types? We have active transport, then facilitated transport, passive, facilitated, then active, and filtration. Okay, and we have to study fixed laws. We have first fixed law and second fixed law. First fixed law is for steady state. Second fixed law is for non-steady state. Okay, so and diffusion through biological membranes. This much you have to remember. Okay, so I hope you people liking my video. Okay, so if you have any doubts, please comment in the comment section. Let me know. So thank you for watching. Bye bye.